So, like, do you guys remember, like, I told you how the data looks? Okay, so it was something like this. Like, let's consider the same example as we considered in the first session. Like, we have here, we can say house price. Okay, and this is number of bedrooms. Okay, so what your data would look like. So we have two bedrooms, it is 30 lakhs. We have four bedrooms, it is around 45 lakhs. Somewhat like as a you have around, let's say, 1,000 data points. Okay, like 100,000. Okay, so this one particular row, like we call as a single data point. Okay, so you have multiple such, and like you can see this in tabular format. Okay, but how can we make some like a deduction or some inference using it so that we can use this particular data so that we would, let's say we are having some new house and someone gives us like it has, let's say, five bedrooms. Then based on that, you predict what is the expected price. Okay, so that kind of deductions we want to make. Okay, so first step in this is so we will come it. So you got the data like in the same format which was here as a tape. You got in tabular format, and you plot it in this. Like this is called a scatter plot. Okay, so let's say X was your number of bedrooms and Y was your house price. Like currently, which I'm showing you, it is a random plot. Okay, so you plot it in this format. So you can see that ये जो X वाला है, this is that what I told number of bedrooms and Y is the price. So you can see कि, like general trend if we see that it is as the number of bedrooms increase, the price also increases. So now what we want is like you plotted it, that's okay. So can we formulate some kind of thing कि हाँ like we can get some form of line, like एक line है which so you have something like this. Okay, so this was bedrooms and this was price. Okay, so what I want is we need a general wait, I will change the color black, let's try green. Okay. So we want this general trend, how this value varies with the number of bedrooms. So you can see that it is a kind of a linear line. And what is the equation? Y equals to mx plus c. So to define this particular line for this particular data, what we need is these two things. One is the slope and one is the intercept. So what we did till now, we had the data, we plotted it, we got to know how there is some linear dependence between these two points, like these two features. And now what we want is we want some kind of relation between them. So what we want, we want this MNC to define this form of relation. And the process of getting this relation is called linear regression. Okay. And coming forward, like this, we consider that we have only one feature. Okay. So, like I told you last time also, कि this price जो है, it can depend on number of bedrooms. It can also depend on the location. Okay, it can also depend on what we can say the area. Okay, if it is a like kind of society, then what floor we have. Okay, so there are many such features which will depend. Okay, so if we are considering only one feature to model this thing, then it is called linear regression. If we consider many such features, okay, so what we call it is a multiple linear regression. Okay, so we will have is, let's say we are having two. Okay, so other we have two features. So we will have in 3D now. So in the first case, we had one feature, इसमें. So we had two dimension plot because एक feature का and one is the price. Okay. So if we have two such features, then we will have three-dimensional plot. This will be price. Let's say this is number of bedrooms, and this is क्या था? Look, let's take location. Okay. So इसमें फिर you will get in 3D somewhat plot. And if you consider beyond two, then you will reach in four dimension, five dimension. But that we cannot visualize. So like we won't go into that much, but we can model it using this algorithm. And like this, we were talking of in this case, our equation will be somewhat like W naught plus W1 x1 plus W2 x2 plus Wn xn, where n is the number of features you have. Okay, so considering this analogy in the simple part, you can consider ये features है, like these are the slopes for every feature, and this is the intercept. Okay, and there can be one more possibility that in this we have one, like its power is one, everything. So if we don't have that, like our equation can be y equals to w naught plus w1 x1 plus w2 x1 square plus w3 x1 क्यूब ऐसे फिर w क्या लो 5 ले लो x1 x2 plus w6 x2 square and some similarly for all other features. So what you did कि इसमें like we had a linear relationship. इसमें you will have like if in two dimensional it can be any curve. Okay. And this we call it as polynomial regression. Okay. Clear? So what we will do is first let's build an intuition. So for solving this, actually we have two types of solutions. Okay. So for linear regression, like currently we will talk only about one variable. Okay, if you understand about one variable, we can directly like take it forward. Like उसमें बस number of variables change हो रहा है W0, W1. So, linear regression. For solving this, we have two methods. Okay, so one is like linear algebra based, and one is an iterative solution. Okay. So linear algebra wala, like we won't go into much depth because like generally it is not used that much. I would just write the like जो parameters है, parameters just like W0, W1, what else we had, is key we have a certain proof and from that which is proof is transpose. Okay, अभी किसी को कुछ समझ नहीं आया होगा ये क्या लिख दिया. Okay, so what I will tell is कि x क्या है, y क्या है ना. तो कंसिडर कि x जो है it is a feature like it is a vector which contain
is number of bedrooms key for every data point. Let's say there are n data points, so it would be a n cross one vector. Okay, so two bedrooms, three bedrooms, let's say n bed, six bedrooms. That's a different we have. And y is the price for that particular thing. Like this is two bedrooms, so what we took here, 30 lakh. This is 30 here. Then three ka we took 45, and similarly. So this is also n cross one vector. Okay. So this X represents our features which are input to the linear regression model. Okay. And Y are the targets, like which we want the model to predict, which is in our case is the price. Okay. Take it as price, and this is number of bedroom. Okay. Yeah. So actually, and this is the number of data points we have. So N can be very large, like say 10,000 or even 1 lakh. So what we will have is we would be multiplying the vector with a dimension of 1 lakh with another vector which has dimension 1 lakh, and similarly. So like this would become a very computationally expensive thing. Okay. So another thing is we have an iterative solution. So for iterative, what we use is like it is an algorithm. So to give an analogy, like in I don't know in 11th or 12th, whatever it was there, you had a chapter in which like we would create some kind of line intersection के which we would see कि हाँ इस पर या इस पर किस पर maxima है. What was the name if anyone remembers? Yeah, linear programming. So what we did in that, it would take one, like for example, if we were talking about something as a cost which would incur, so we would see the in points per, like whichever gets the minimum, we will take that. And if we were talking about reward, then just for maximum RI, we would take that. So what we were doing is we were finding some sort of like features, like the X and Y consider in our analogy, these are features. So we are finding the values of those features so that we can have the maximum or the minimum output which we require. So optimization is just the thing. We need to find the values for the features or the parameters which we have so that we can get what you can say our output. Like if we are talking about cost, it should be minimum. If we are talking about reward, it should be maximum. So whatever we are considering, we want it in the best value. So this process is called optimization. To come into iterative solution, so पहले बताने से पहले I would give you an intuition. So what we do is ये data points है हमारे पास. We directly sample, like randomly we take a value. Uh, let's open it. So in this particular we have y equals to mx plus c. So what we do is c and m value, we randomly assume something initially. Like for starting, initially we take it something, and then we will get इसकी क्या होगा, slope will be almost point some 0, 0, 1. Let's take it that, and intercept is this is m, and intercept will also be something minus 0.02. Let's say. Okay. तो ये हमने randomly sample कर लिया, and उसके basis पर we took this, and our data points we had like x हमारे पास था कि number of bedrooms क्या थे. So we had 0.01x minus 0.02. दिस इक्वेशन वी हैड एंड एक्स जो था वो हमारे पास वेक्टर पहले से था नंबर ऑफ बेडरूम्स का 2 3 वॉट एवर 7 एंड ऐसी एन सच वैल्यूज थी ओके सो व्हाट वी डू इज ये हमारा एक मॉडल का एस्टिमेट है दिस इज एन एस्टिमेशन लाइक आई नो इट इनिशियली we have initialized this randomly but let's consider कि हाँ this is somewhat correct not exactly correct but somewhat correct so based on that you will take compute this y value using these x okay so it won't be correct so whatever prediction we are getting I'm terming it as y hat and using this you will get some vector which will also be n cross 1 okay so these are you will take this ये जो है these are number of bedroom actually and these dots represent your actual value and ये जो line which we estimated initially randomly था so we plotted it and you can see that it is not as per like not correct okay then what we want is we want some kind of algorithm so that we can refine these values so that ये लाइन जो है it will come exactly in linear. So let me show you. This was the first initially randomized. Then we performed in the first iteration. So you can see it is coming at least it is becoming better somewhat. Okay, how many of you can see? Yeah. Then we performed one more iteration. You can see it is becoming more like aligned. Then we go like we do it for certain number of iterations and we get the like max best estimate which we can get. Although we would not get exactly the her points this are this should match, but somewhat like trend we can capture because there you can see these do not lie in a straight line. There are some noises like this along this is a little bit that side, this is a little bit that side. But we are able to capture the trend. Okay. Define a term which is law, like not exactly law, it's mean squared law. Okay. So loss, what you understand by loss? Okay. So as is what more is the number of data points not following the expected regression. Well, somewhat correct, okay, so but not exactly. So loss is basically that uh, let's say you had the actual values like data में हाँ दो bedrooms के लिए it was 30 lakh so this is the point of fun. So this is actual like actual or say true value of price okay so we would denote it as y okay and later when you initialize this thing let's say you initialize this is randomly point zero 0.01 and point zero 0.02 so based on this you computed for every x and we denoted it as y hat okay so one was y which was the true and one is y hat which is from our randomly initialized value randomly initialized model so we know that this was not correct because we saw in this uh, graph that yeah, it was not coming exactly correct. Okay, so we need to find the difference. Key, like if we want to correct something or we want to optimize something, we need to know कि हाँ ये कितना okay. So for that only we would define our mean. पहले तो loss. Okay, loss is y hat minus y. जो हमने प्रिडिक्ट किया एंड द डिफरेंस बिटवीन द ट्रू वन. ओके, क्लियर टिल नाउ? लॉस का क्या हुआ? एंड देन इज स्क्वायर्ड. देन व्हाट वी डू, इसको स्क्वायर कर देते हैं. ओके, स्क्वायर तक ओके. देन देयर इज मीन. अब मीन कहाँ से आ गया भाई? ये तो एक वैल्यू का था. बट व्हाट यू विल सी इज कि ये जो y था, y वाज अ वेक्टर n क्रॉस 1, क्योंकि we had n data points and for every we had some value where this was 30 lakh, this was 45 lakh and whatever. And x भी हमारा वेक्टर था. तो like basic वही है, what we say, like matrix multiplication, normal multiplication with a matrix. So y hat will also be a vector. तो अब क्या करा, y hat माइनस y, ये भी एक वेक्टर होगा n क्रॉस 1 का. ओके, ये समझते हो? एंड व्हाट वी नीड, अब हमें मीन चाहिए. तो व्हाट वी विल डू, वी विल टेक इट एज अ समेशन I equals to 1 से n y I y at I. ओके, ये क्या किया, समझ आया? Like we are taking the difference between 30 and whatever we predicted, 30 minus this one plus 45 minus the second value. Okay, and then like उनका square भी करा and then we summed it up and mean था, so we divided it by 1 by n. Okay, got it? How we defined it? Okay, so this was mean squared loss. We got ki how much difference we have. Now we need an algorithm so that which takes this loss and these weight and optimizes it so that we can have a true estimate. Okay. So if you would see कि जैसे okay, ये था, then y hat I क्या था? Y hat I जो था, what you can write is, जो हमारा 0.01 x I minus 0.02. Okay, so what I am doing, I am substituting it in this. So what we will get is 1 by n summation I equals to 1 to n, then 0.01 x I minus 0.02 minus y. That's 12. Okay, ठीक है, I substitute. Now, क्या होगा? What you need to do, ये जो value है 0.01 and 0.2, as we move along iteration, ये slope and जो intercept था in this, you saw that slope and intercept was changing. So rather than keeping it as the constant, I will denote it. What I will do is I will take some variable to denote it. Okay. So what I am doing is, like say mx plus c ले लेते हैं, so m into xi plus c minus y. Okay. So this m will be initialized to 0.01 and c will be initialized to minus 0.02 in the first iteration. But along the iterations, when we are optimizing it, its value will change. So what I am doing is, rather than keeping directly those values, I am taking a variable to denote those values. So if you see correctly now, what I will make is, I will make graph. Two graphs बनाऊंगा. And one more definition, like before going forward, like these M and C, like these are subject to change. Okay. So the values which are subject to change during the iteration or the optimization process, we call those parameters. Okay. Just definition है, like nothing but needed. Okay. तो अब ये था हमारा लॉस. ओके. So let's say I am computing the plot between loss and M and another plot between loss and T.
Right. Okay. So ये कुछ ऐसा सा आएगा. Okay. How many? So consider कि this loss value is based on some M and C value. Okay. ये understand कर सकते हो. And based on this diagram, you can see there exists some value of M at which the loss is minimum and some value of C at which loss is minimum for C. Okay. So अब हमने let's say it was something we started हमने M क्या लिया था 0.01 and minus 0.0. So this was let's say this was M and this was 0.01. And let's say हम इस पर थे इस पे we were at right side it was minus 0.02. Okay, ठीक है. अब what you can see is कि हमें in case of this we need to move our value of m forward so that loss decreases. And in this case we need to move loss like not loss value of c a little bit backward so that loss is minimum. Okay, so for that like one thing what you can have is uh, when you compute loss. So I will tell you that first, before going into that, let's discuss the basic process. Okay. So first process is initialize parameters uh, randomly. Okay. We initialize all the parameters randomly in the starting. Then second process, let's take we are for loop here, and then in that we first compute loss. Okay. Then loss compute करने के बाद optimize or change the parameters. Here parameters are what? M and C. Okay, and then you loop throughout this process, and at the end, for you do it for some number of loops, let's say 10, 100, and then after that you will have like the parameters would be close to these values. Okay. 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 So अब क्या करना था we had to move these randomly initialized value to these optimized values. Okay, so first thing like we had this loop था we need to change these values. So what we can do is हर loop में like m plus equals to m plus 0.1. Like you take it first iteration था you add 0.1 to it. Then second iteration, you add 0.2 to it. मतलब 0.1 ही. Then in the next iteration, you add more 0.1 to it. Then more 0.1 it. And then it will come near about this. Similarly, इसमें you got to see कि हाँ ये हमें इधर लाना है. So what you do C equals to C minus तो ये C equals to C minus 0.1. Then ये ऐसे कर करके you got here. Okay, this is one way. But can anyone tell ki what is the disadvantage of this particular way? We may pass the maximum. Yes, absolutely correct. Okay, so currently this value 0.1 is okay, but consider.
कि like you don't know, तुमने ये ग्राफ प्लॉट नहीं किया, and you had this plot and you said मैं तो m equals to m plus 10 लूँ, है ना? अब मान लो we were at what 0.01, है ना? And this minima was at let's say 2.75. अब तुमने सीधे 10 तो ऐड कर दिया, बट आफ्टर एडिंग दिस यू रीच्ड हियर 10.01 पे, है ना? अब तुम माइनस भी करोगे तो तुम ऐसे ही यहाँ इधर कहीं आओगे, सो व्हाट यू विल डू, तुम मिनिमा पे पहुंचने की जगह यू वुड बी फ्लक्चुएटिंग हियर एंड देयर, है ना? दिस इज फॉर बिगर वन, एंड लेट्स से इफ यू कीप अ वेरी स्मॉल वैल्यू, let's say same example 0.01 पे था, this was at 2.75, and what you did, I will take m equals to m plus 10 to the power minus 3, मतलब 0.001। अब तुम इसे रेंगते पता नहीं कितने सालों बाद you will reach here, God knows about that, okay? So deciding this value कि हमें कितना ऐड करना है, that is क्या हुआ, that okay, so Shirisha, coming to your doubt, ki 0.1 or any number, like we can't directly choose this value. Like for that, हमें खुद को like that person needs to involve in the process and see कि हाँ कितना add करना. And generally, if you talk about current, like these chat GPT and these stuff, you know. So let's search it online. Okay. So if we talk about number of parameters in GPT-4, see 1.76 trillion. Now, if you have this much number of parameters, do you think कि एक इंसान बैठ के he would see कि हाँ एक पैरा इस वाले पैरामीटर में I need to add this much value, इस वाले पैरामीटर में I need to add this much value. So like this is not a correct way, or like if you have that much number, then it would take I don't know how much time कि एक value निकालने के लिए. Okay, so you are, है ना? So we understood कि why this approach is not that good. So what we will do is we will take a new approach. We had this thing, we graph था. This was, we started with 0.01 and ये कुछ भी था. Okay, now we don't need. So what we want is जब हम इस like we are at a far more stage, we want कि our steps should be high, like it should take longer steps, but when we are near this, we want our steps to be small. Okay, so that is the thing. So can you suggest something, like I would give you a hint कि see कि यहाँ पर स्लोप क्या है, यहाँ पर स्लोप क्या है, दिस इज sprint is slope, and can on the basis of slope, can we come out with some way. So let this was loss, this was M, है ना? So we were here and this was loss and this was C. In that case, we were here. Okay. So here you can see that slope is like high negative. Okay. And we want our M to increase. Okay. So can we write as M equals to M minus this slope. So M minus and slope is high negative, so it will come M plus something. Okay, so you would move it
somewhat forward. And as we come here, let's say we solve this for two, three iterations and we reached here. So here the slope compared to here is like low, not low, like I'm not getting the good word. It's small negative. Okay. So it small negative है. So if we will see कि पहले जो slope था at this point, it was high negative. So this term which was adding completely जो था, we were having m equals to m plus some big number. And at this point, what we have is m equals to m minus small number. So it is m plus small number. Okay. So I think like you can see we have solved that problem कि हमें कितना add करना है. And it should depend on the basis where we are at this graph, like on the current value of m. Okay. To this graph. Okay. So here क्या है, यहाँ पे जो slope है, it is high positive. Okay. So high positive है, and we need to decrease our c. So we can write as c equals to c minus this slope. Okay. So it will come c minus this is positive. So ये पीछे ही आएगा. Okay. And at this point also we can see कि ये slope जो है this is small positive. Here also c minus small positive will come at small steps. Okay. So if we take our equation as m equals to m minus slope. In general, parameter, let's say parameter नहीं लेते. Uh, हम actually if we talk in terms of analogy, the parameters होती है we denote it as W. W इसलिए we call these as weights. Like this is the terminology which we use. So like nothing much, बस एक नाम है. So we can denote it as W equals to W minus. अब ये slope. What was this slope? This was derivative of loss with respect to derivative of m in this case. And here, derivative of loss with respect to derivative of c. Okay, clear? Okay. So we can write it as derivative of loss divided by derivative of w. Okay. So this is the what we can say gradient descent equation. Okay. So gradient कहाँ से आया? From this term. Descent कहाँ से आया? We are descending towards lower loss. Okay. नाम समझ आया? क्यों ये नाम है और इक्वेशन कैसे आई? Okay. So whether you study linear regression or whether you go and build ChatGPT, at the back end optimization के लिए यही यूज हो रहा है. Okay. ठीक है. Like consider this is क्या बोले इसको, like कोई अच्छा शब्द सजेस्ट करो, like which we can say is like master equation. Okay, you can say it like this is the master equation which we have. Okay, and like there are some what you can say updated versions. Like इसमें भी like you can say कि क्या होता है, ये वैल्यू जो ग्रेडियंट है like this can also vary कि like sometimes we want कि हमें जो इसका ये प्रोसेस है ग्रेडियंट से वी आर कमिंग एट अ लोअर लॉस वैल्यू, वी वांट टू कंट्रोल दैट आल्सो. सम पीपल से दैट, सो दे इंट्रोड्यूस सम अल्फा. अब इस अल्फा को मल्टीप्लाई कर देते हैं विद दिस ग्रेडियंट एंड वी कॉल दिस अल्फा एज लर्निंग रेट. ओके, जस्ट एक वैल्यू है. we pass it while trading generally 0.01, 0.001 इस range में होती है. So this is just to control ki how fast like this complete process happens. Nothing much. Okay. Okay. So यहाँ तक clear है. Okay. ये सब तो हुई theory. अब आ जाते हैं code part पे. Okay. So what I have done is कि this particular part ये यहाँ from the starting till यहाँ तक observation तक. What I have done is I have coded this same concept. Okay, ये derivative with respect to W naught. Okay, so formulation नहीं लिखी. हाँ. So this is our equation y equals to W naught x plus W1. Okay, so W naught slope and W1 is your y-intercept. And this learning rate I have taken as 0.001. Okay. And these are the derivatives, ki like how ये y prediction wala. Okay. So if you would simply look, this first code is custom implementation of that thing only. Ki, W0, W1, I initialized it randomly. Okay. Then epochs, like generally iterative solution होते हैं. So epochs is just the number of time we want to iterate. Okay, epochs, I think we have set it 5. So first I predicted it, W naught x plus W1, which we have initialized randomly. Then we calculated the loss, same formula. Okay. Then this is, we plotted the loss, like this is the like plotting thing. And ठीक है, ये सब not that चीज, but see this equation. W naught equals to W naught minus learning rate into derivative with respect to W naught. Okay. This is the same as this thing. How? Same thing with W1. Okay. And we are doing this like over the number of iterations. And then you can see that initially randomly tha. Then we improved it somewhat. Then thoda bahut improvement more. And then at the end, like we have done it for 5, but you can try to change the hyperparameters. Yeah. What I want, the number of epochs change karna, learning rate change karna, and try to experiment it with it. If you would lower the learning rate, then you would require more number of epochs. If you would set the learning rate to I, या तो it will not learn properly. Yes, कुछ होगा. So try to experiment with it. So this is the implementation जो हम खुद लिखते हैं, but you won't write it every time on your own. Okay, so considering ये तो एक ही feature में था, but when you have more number of features, like it would become a little bit complicated because जैसे if let's say you have 100 features, then this W's you will have 100. Okay, so हर उसके लिए you will लिखना it's not that much, like no one likes to write it again and again. So this is a library, scikit-learn. Okay, so this is scikit-learn. So you can check it out at this. So it is an open source library and you can do very much tasks. So go in regression and you can try to explore. So for installing, सबसे पहले, if you are doing it on your local system, so write pip install scikit-learn. Okay, it will install it for you. है ना? If you are doing in Google Colab, it would be already installed. So इसमें क्या किया? Like there is already a data set of diabetes which is already loaded in this library. So I am loading that data sets, and in that, what is first we'll see the description. See what features it contains. So one is age, which is in years, then a body mass index, then the sex is there, then average blood pressure. This S1 represents serum cholesterol low density. So these are different features which you can say which affects diabetes, and moreover, like blood sugar level is there. So these are all the features still here, and this target. is the like final क्या कैलकुलेट कर रहे हैं हम डायबिटीज का जो भी like index होता है what they are doing like I don't know. So this is what we need to find a linear relationship with using all these features and this target label. Okay. So what I have done is we have plot some like data analysis part. So we will try to see the correlation between target जो हमें predict करना है and the body mass index. Okay. So this is the scatter plot and you can see target and body mass index में there is 0.58 correlation. Okay, and this color represents the gender. Okay, male and female. Then later you have the relation with the blood pressure. Okay, it is the correlation is coming out 0.4. Okay, correlation is like in simple words. Like I won't go into the mathematical definition. Just for intuition, let's say there are data points है जैसे x and y था हमारे केस में. So what we have is we have a graph. What example? कुछ अच्छे we should take a good example. Same number of bedrooms and the price. Okay. So what we saw it was a positive for मतलब, as the number of bedrooms increase. So the prices also increase. So this denotes a positive correlation. Positive correlation. What it means is as number of bedrooms, which is on x-axis, increases, price increases. Okay, clear? Negative correlation क्या होगा? Someone tell that. Will it be as number of bedrooms decreases, price decreases? क्या ये होगा? नहीं. क्यों नहीं होगा? Increases. Yes, exactly. Because if we are moving in this direction, the bedrooms increase कर. So this is the wrong definition of positive. Sorry, negative for. Yeah. So this is same as positive correlation. For negative, what we will have is number of bedrooms increase, but the price decrease. So उसमें we would have is something like this. ऐसे ग्राफ आएगा. Okay. Okay. So these are the values. Like if you want to see mathematically how it is, you can try to explore. Like, but we won't go into that. So the target at the blood pressure, like as is, we have calculated the correlation for everything. Okay. So the general thing is, listen this very carefully. If you want to model a relationship between two features, okay. Let's come here. Let's say this is target and this is some feature f. If the correlation between them either positive or negative, if the correlation's absolute value is high, then agar if you change the f value, you can see some difference in the target. Okay, like so it is a good feature. Easy terms में one is this same price. And what else can we take? Hmm, what else can we take? This is the price of house, and let's say your JE rank. बहुत गंदा एग्जांपल है बट ठीक है. सो मानो तुम्हारी जेई रैंक जैसे जैसे बढ़े, इट्स नॉट नेसेसरी दैट प्राइस ऑफ हाउस इंक्रीज करेगा, है ना. लाइक इफ यू सी एट द डेटा देयर माइट बी, हाँ कुछ कोरिलेशन आ गया, बट in general, based on our intuition, we can say that like this won't affect this that much. But consider ki the data which you got from this, there is one more column of J rank. जो परचेज कर रहा है उसकी जेई रैंक है. सो बट उसका लाइक कोरिलेशन इज कमिंग अबाउट 0.01 0.02 समवॉट दैट मच. सो यू कैन सी कि based on this there is not much relation between them कि अगर तुम जेई रैंक को बढ़ाओगे या घटाओगे, so price of house में there would not be much difference accounted for that. Okay, so this is the same thing. So क्या होता है, you calculate the correlation जिनमें you have a correlation which is like this is 0.5. It is a good correlation and can be considered. But if you say this is point 2, बहुत कम है. Like we don't consider it that much. I know. So see 0.17. This is very less. So we should like not try to include this in our modeling because क्या होगा? जैसे currently we are talking about like this is कितने थे? Like 1, 2, 3, 4, 5, 6, 8. Around 9 to 10 features are there. Okay, so we would have around 10 to 11 parameters to optimize. But consider the models which we have like ChatGPT, जिनमें like we have 1.74 trillion. यही था ना number? Like near about इतना ही था. Okay, correct me if I am wrong. Okay, इतना ही था. So if you have that much, so if you increase randomly चीजें, so this would increase the parameters to be accounted for that. Increase like include them because you can see कि इसमें JEE rank का house of price में there is no thing. Okay, so that's the basic analogy. Try to like you can get it. You can see the functions which are there. Like इसमें we have used, and this is the heat map. Okay, heat map पे आने से पहले ये correlation इसका सब समझ गए. You understood कि क्या बोल रहा था मैं in the last 5 minutes? Okay. So if we want कि ऐसे अलग अलग like जैसे we have plot I think around 9 to 10 plots we have plotted. So to not plot this, we have something called heat map to plot it. So what it does, it looks like this. Don't get afraid. क्या होता है? See, we have these all features: target, S6, blood pressure, BMI, age, type, and this side we have. So क्या होता है? Target का we calculate correlation. Target ka with target, it would be one because like with itself it will correlate 100%. Then the correlation of target with S6. S6 क्या था? S6 was our blood sugar level. Okay. So correlation of target with blood sugar level is 0.38. Similarly, S5 के साथ भी is 0.57. So you can see it with all. And among the features, so that कि age और BMI कितना correlate कर रहे हैं. So age is here, BMI is here. So age and BMI correlates 0.19 of times. Okay, so sometimes what happens is if you have two features जो correlate almost same कर रहे हैं with itself, so we don't need to like जैसे example to explain it easily. We can what we can have is correlate. Now, similar example, J advanced की rank और J mains की rank. Very poor example, but consider this. Like generally क्या होगा? In general case, there are certain exceptions. कि this is mains rank, this is advanced rank. Generally, it will be correlated, like around approximately one ही आएगा. You agree? स्क्रीन दिख रही है ना? Okay. So अब क्या है, if we use these two features differently, there is nothing much कि like कोई भी यूज कर लो, like it will be approximately same trend ही होगा. जिसकी मेंस में हाई थी, it advanced में भी like it would be high only. Okay. I am not saying कि this is always correct. There are some cases जिसमें like these are not correct, but we would not go into that. Generally, this follows this like positive correlation which is near about one. Okay. So if you have two features, like तुम किसी का कुछ मॉडल कर रहे हो and you are using these two features, but you see कि हाँ इनका correlation like same ही है. But do you think कि we should use these two differently? Or can we use this thing like इसमें से कोई भी एक we can use? The thing is कि तुम्हें क्या करना होता है, you need to select only those features which are required and necessary. Like you will get, if in real world data sets you will see कि there are very like बहुत सारे होते हैं and we don't need to account everything. We need to do feature extraction and उसमें से we need to account only the required and good features which can help us make a good and robust model. Okay, so that is the only thing which I want to emphasize. And using this correlation, what you will do, you will you need your y column is the target column, and x is everything else, which are these all features, age, sex, BMI, and all. So you separate it out. Then in sklearn we have this like क्या होता है डेटा को भी you need to like split it into two types. One is the training and testing. Okay, similarly, as we have like in class we study, that is the training phase. And exam mein what we studied, we are tested on that. So that is the same thing. We first train the model and it learns some patterns and then we test it on some data. Like and these two data should be different. Like ऐसा like sometimes it happens कि जो questions we were taught in class that comes into the exam, but here we need to make sure that both the data sets are different. Okay. Okay. So like it's just like and so from sklearn we import our linear regression model. Then uska ek like we make an object and then fit function what it does this same part training part which we आ गया this particular loop वाला जो part था like initializing it randomly and then this training part and optimizing the parameters. So this is done by this fit function. Okay. Then after training, like we calculate the mean squared error based on the test set. Okay. Then वो error निकाला. Then like what we can do is we at the end we need these coefficients. जैसे for example here कितने थे 1 2 3 4 5 6 7 8 9 10 10. Okay, so coefficients कितने हैं 1 2 3 4 5 6 7 8 9 10. So for everyone, every feature we have one coefficient which needs to be multiplied by it and some constant term which is to be added. Okay, so at the end we can get this exact value, and like this is all like which I wanted to convey. So for you, like what I want is try to see it with different data sets and experiment with this part. Okay, I will share this notebook with you. Make a copy of that. What you need to do is optimize, like change these values of learning rate and epochs and see how it varies. Okay, so I think this was all. Why do we use learning rate? Okay. So in learning rate, wait, so, so I told you that what we can have is we can like कहाँ गया वो graph? हाँ. So in slope also what we can have is we can have like अगर slope बहुत ज़्यादा है so we can also have this thing like it can first it is here then if slope is very much high then it can go here. So what it can be, it keeps on fluctuating between and does not reach the optimum value. So to control this, what we apply the gradient with something which can control the movement. So we don't miss the optimum as we were missing in this case. So that's the basic idea of learning rate. Okay.